Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Python modules, Part 1, for the Class 11 students of Computer Science. Let's dive in and get started. Welcome to the fascinating world of Python modules. Let's start learning about modules in Python. Have you heard about the term modules, but what exactly are they, and why are they so important? Modules in Python serve as organized containers for code, much like compartments in a toolbox. Just as a toolbox keeps similar tools together for easy access and organization, modules group related functions, variables, and classes in a Python program. For instance, imagine a toolbox where all screwdrivers are kept in one compartment, wrenches in another, and so on. Similarly, in Python, a module could contain functions for mathematical operations, another for handling file operations, and yet another for working with dates and times. Each module encapsulates functionality that can be reused across different programs, much like referring to different chapters in a book for specific topics. This modularity allows developers to efficiently manage and maintain their codebase by separating concerns and promoting code reusability. So, when we import a module into our Python script, we're essentially accessing a collection of related tools or information that we can utilize to accomplish various tasks within our program, making our code more organized, understandable, and versatile. In Python, a module is a file containing Python code that defines functions, classes, and variables that can be used in other programs. The set of functions stored in a file is called module, and this approach is known as modularization. Modules help organize code and promote code reusability. They allow you to break your program into smaller, more manageable parts. Commonly used modules that contain source code for generic needs are called libraries. Let's discuss about module creation. You can create your own modules by writing Python code in a .py file. Each file represents a module, and its name is usually the same as the file name, excluding the .py extension. A module in Python is a file that contains a collection of related functions. Therefore, when we speak about working with libraries in Python, we are in fact working with modules that are created inside the packages, or we can say it as library. Thus, a Python program comprises of three main components: library or package, module, functions, or submodules. Let's see the relation between module, package, and library in Python. Module. A module is a file containing Python code that can define functions, classes, and variables and statements with .py extension related to a particular task. A module allows us to organize our code by grouping related code, which makes the code easier to understand and use. Package. A package is a directory of Python modules. It is a namespace that contains multiple packages or modules. It is a directory which contains a special file $init_.py through which Python interpreter interprets it as a package. Library. A library refers to a collection of modules that together cater to specific needs or applications. For example, Math Library of Python caters to mathematical computations, NumPy library deals with scientific computing, etc. Let's learn about the objects in Python module. Docstring. String literals enclosed with triple quotes that appear right after the definition of a function, class, method, or module. It is mainly used for documentation and can be accessed using _doc _attribute. Variables and constants. For storing values. Classes. To create blueprint of any object. Objects. Object is an instance of class. It represents class in real world. Statements. Instruction. Functions. Group of statements to perform a specific task. Let's see the advantages of Python module. Code reusability with modules. Let me explain. Modules facilitate code reuse by allowing the importation of module functionality into other Python scripts, reducing redundancy and promoting efficient development. Next advantage is organized and documented boundaries. Python modules create well-defined and documented boundaries within a program, aiding in code management and maintenance. Next advantage is logical organization. Modules enable logical organization of Python code, enhancing readability and facilitating collaboration among developers. Next advantage is improved understandability and usability. Grouping similar attributes into modules enhances code understandability and usability, providing a structured approach to organizing code and simplifying access to specific functionality. First, we can discuss about modules. A module is a single file containing Python code that defines variables, functions, and classes. Let me explain this with an example. If the content of a book is not indexed or categorized into individual chapters, the book will become boring and complicated. Hence, dividing the book into chapters makes it easy to understand. In the same way, Python modules are files which have a similar code. Thus, a module simplifies a Python code where classes, functions, and variables are defined. Now look at the second point. It serves as a way to organize code and make it reusable by allowing you to import its contents into other Python scripts. Modules can be small, containing just a few functions, or larger, encompassing several related functions and classes. Examples of modules in Python include math, random, and datetime. Look at the first box. How to create a module. To create a module, just save the code you want in a file with the file extension .py. Example, save this code in a file named mymodule.py. Def greeting of name, : print, hello, plus name. Now look at the right side box. How to use a module. Now we can use the module we just created by using the import statement. Example, import the module named mymodule and call the greeting function. Import mymodule. Mymodule.greeting of Sam. There are several built-in modules in Python, which you can import whenever you like. Let's discuss about Python module names. A module name is the file name with the .py extension. When we have a file named empty.py, empty is the module name. The _name is a variable that holds the name of the module being referenced. Let's see this example. Import random. This line imports the random module from the Python standard library. After this line executes, you can use functions and classes from the random module in your code. In line 2, random.name . This line accesses the _name attribute of the random module. In Python, modules have several attributes, and _name is one of them. The _name attribute is a built-in variable that holds the name of the module as a string. Output of example 1 is random. The reason for this output is that the _name attribute of the random module is set to random. In other words, the value of random.name is the string random. Look at the second example, line 6. The _name attribute is particularly useful when you want to determine whether a Python script is being run as the main program or being imported as a module into another script. When a Python script is executed directly, its _name attribute is set to _main . If the script is imported as a module in another script, the _name attribute will be set to the name of the module, in this case, random. Look at the code of example 2. If you have the following code in a script called example.py and if you run example.py directly, Python example.py, it will print. Now look at the output. This script is being executed directly. This is some underscore function in example.py will be printed. However, if you import example.py in another script, the if double underscore name double underscore equals double underscore main double underscore block will not be executed, and only the functions and classes defined in the module will be available for use. To use a module in your program, you need to import it. Python provides import keyword to import modules in a program. You can import the whole module or specific parts of it. The import statement is used for importing modules. There are two methods to import modules: importing entire module and importing selective methods from a module. Let's see one by one in detail. Importing entire module. To import an entire module in Python, you can use the import statement followed by the name of the module. Syntax is import module underscore name. For example, let's say you have a module called math.py that contains various mathematical operations. To import the entire module, you would use import math. It gives access to all the functions of math module. Next is to import multiple modules in a program. Syntax is import module underscore name 1, module underscore name 2, and so on. Example: import math, time. This will import two modules in a program. Next is, we can access any function of the imported module by using dot notation. Example: math.sqrt function. Importing the entire module may load more code into memory than necessary. If you only need specific functions or variables from a module, you can use the from statement to import them selectively. Now, let's discuss about importing selective methods from a module. To import selective methods or entities from a module in Python, you can use the from statement. This allows you to import all or specific functions, classes, or variables directly into your code without referencing the module name. Syntax is from module name import star. Example: from math import star. It gives access to all the functions of math module. Next is to import a particular function of the module. Syntax is from module name import method name. Example: from math import sqrt. This will import only sqrt function from the math module. Next is to import multiple functions. Syntax is from module name import method 1, method 2, up to method n. Example: from math import sqrt, pow, pi. This will import multiple functions, that is, sqrt, pow and pi functions of math module in a program. Let's see some examples. Line 1 imports the sqrt, pow, and pi entities from the math module. Now you can use these entities directly in your code without referencing the module name, math. In line 2, the sqrt function is imported from the math module, allowing you to calculate the square root of a number. In this line, it calculates the square root of 625, which is 25.0, and printed. In line 3, the pi constant is imported from the math module. It represents the mathematical constant pi. In this line, it is printed after rounding it to 2 decimal places using the round function. The output will be 3.14, which is the rounded value of pi. In line 4, the pow function is imported from the math module, allowing you to calculate the power of a number. In this line, it calculates 3 raised to the power of 3, which is 27, and printed. To import all methods from a module. Syntax is from module name import star. It imports all the functions and constants from a module. Example: from math import star. This will import all the constants and functions or methods of math module. Let's see some examples. When you use from math import star, it imports all entities from the math module into your code. This includes functions, constants, and other entities defined in the math module. Look at line 1. This line imports all entities from the math module. It allows you to use any function, constant, or other entities from math without explicitly mentioning the module name. In line 2, the pi constant is part of the math module and represents the mathematical constant, pi. Since you imported all entities from the math module, you can directly access pi. The value of pi will be printed, which is approximately 3.141592653589793. In line 3, the factorial function is part of the math module. It calculates the factorial of a number. In this case, factorial of 5 calculates the factorial of 5, which is 120 and printed. In line 4, the sqrt function is also part of the math module. It calculates the square root of a number. In this line, sqrt of 225 calculates the square root of 225, which is 15.0 and printed. Let's see the key points of import statement. Import statement is the simplest and the most common way to use modules in our code. For example, import math. On executing this statement, Python shall perform 3 operations. Search for the file, math.py. Create space where module's definition and variable will be created. Execute the statements in the module. Import statement does not directly import the functions and constants in the program. To access or use any of the functions present in the imported module, we have to specify the name of the module followed by the name of the function, separated by a dot, also known as a period. This format is called dot notation. Let's see this example. Line 1 imports the math module, which is a standard library module in Python that provides various mathematical functions and constants. Line 2, the sqrt function is part of the math module. It calculates the square root of a number. In this line, math.sqrt of 144 calculates the square root of 144, which is 12.0 and printed. Retrieving objects from a module. There is another function dir, which, when applied to a module, gives you the names of all that is defined inside the module. Let's see an example. When you pass an object as an argument to dir, it lists the attributes and methods available for that object. Here, area is passed as mObject as an argument to dir function. You can see the output, how it has listed the attributes and methods available for area module. From the previous examples, we have observed that import statement in Python can be represented in any of the following for importing module in some other program. Let's recall. Point 1. Import test. Imports the module test and creates a reference to that module in the current calling program, or namespace. After executing this statement, you can use test.name to refer to the objects defined in module test. Point 2. Import test1, test2, test3. This statement shall import 3 modules, namely test1, test2 and test3 in current namespace. As a result, all the definitions of these modules are available and can be used as module_name, name. Name represents the submodule or any object. Point 3. From test import star. When you use import start statement, it shall import all the submodules or objects defined in the module test into the current namespace. So, after executing this statement, you are required to simply give the name of the object to be referred to, defined in the module test. In other words, name would now be used as name only, without specifying module's name, that is, test.name is not required to be given. If name was already defined, it is replaced by the new version, the one imported from the module. Point 4. From test import T1, T2, T3. This statement shall import the module test and create references in the current namespace to the given objects. In other words, you can now use T1, T2, and T3 in your program without specifying their module's name along with them. Note: whenever we are using a module in our program, for that module, its compiled file will be generated and stored in the hard disk permanently. Let's learn about module aliasing. Module aliasing in Python refers to the practice of giving a shorter or more convenient name, alias, to a module when importing it. This can be helpful when working with modules with long or complex names, or when there is a possibility of name conflicts. It allows you to use a shorter name to refer to the module's contents without affecting its actual name in the Python standard library or file system. Module aliasing is achieved using the import statement. Syntax is import module_name as alias_name. Here's an example of importing the math module and giving it an alias m. In this example, we can use m instead of math to access the functions and constants provided by the math module. Similarly, you can also use aliasing when importing specific items from a module using the from module_name import item_name as alias, which is the syntax. In this example, square_root is an alias for the sqrt function from the math module. Remember that while aliasing can improve code readability, it is essential to use meaningful aliases that convey the purpose of the module or item being imported. Overusing very short or cryptic aliases may make the code harder to understand for others and yourself in the future. Let's discuss about locating modules. When you import a module, the Python interpreter searches for the module in the following sequence. Current directory. Python looks for modules in the current working directory of your script or interactive session. This allows you to create and import your own modules easily. If the module isn't found, Python then searches each directory in the shell variable Python path. So, what is Python path environment variable? The Python path environment variable can be used to add custom directories to the module search path. By setting this variable, you can tell Python to search for modules in specific directories not included in the default sys.path. Finally, if all else fails, Python checks the default path, which is the location where Python has been installed on your computer screen. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos. Python Modules Part 2. You can check the link in the description box below.